Okay, so here we're going to do another rational, simplifying rational exponents problem, and I'm going to arbitrarily pick some numbers here. I'm going to say x to the 1/3 times y to the -1 times x to the, let's make it -1/2, and we're going to put that all, we're going to raise that all to the -2nd power, and we're going to divide all that by x to the 1/3, or let's make it 1/6, just to make it interesting, and then y to the 1/2. Okay, so what I want to do is I want to get rid of my rational exponents, or my fractions, from the denominator, make this all an integer, and get rid of all my negative exponents both in the numerator and the denominator. So I'll go ahead and simplify the top first, the numerator, by using the power to power rule. So I get x to the 1/3, that stays as it is, of course, and then I'm going to multiply -2 times -1 to get y to the +2, and x to the -1/2 times x to the or raised to the second -2 power is x to the first power. And I'll put a 1 there just for fun there, and then all over x to the 1/6, x to the first. Well, guess what? X to the first, both in the numerator and the denominator, cancel out, which is great because we can now rewrite it as x to the 1/3 times y squared all over x to the 1/6, and that's it. Now the question becomes is, how do I get rid of the fractional exponent in the denominator? Well, I know that if I want to change this fraction to an integer, I'm going to need to multiply by x to the 5/6. Now, why am I multiplying by x to the 5/6 both in the numerator and the denominator? Because I know that when I multiply by x to the 5/6 and I add 1/6 plus 5/6, I'm going to get 6/6, which is the same thing as 1. So what I really have now is x to the 1/3 times y squared times x to the 5/6, all divided by x to the first power. Okay, so this became that. Alright, so now I can combine my numerator, my x terms in my numerator, and what I have to do is find a common denominator. I have 1/3 and 5/6, so let's find a common denominator. 1/3 plus 5/6 is the same thing, and my common denominator will be 6. 3 times 2 is 6, and 2 times 1 is 2, and 6 times 1 is 6, and 1 times 5 is 5. So my final fraction looks like 7/6. So 1/3 plus 5/6 is 7/6. Okay. So I can rewrite it as, I'm going to write it over here. This term or expression becomes x to the 7/6 times y to the 2nd power, all over x to the first power. Okay. Now I could simplify it even further too, because I know that 7/6, I know that when my power is higher than my index or my denominator, what I really have, if we write this as a radical, is x to the 7th power and taking the 6th root. Well, that's the same thing as x times the square root of x, or x times x to the 1/2 power. Okay. Well, this x here is x to the first power, so what I really have is x to the first power times x to the 1/2 times y squared over x to the first power. And guess what? We have another cancellation here of x's. So our final answer is going to be x to the 1/2 and y squared, and that's pretty much it. You won't receive anything like that on the test, but I would like you to understand how we got from where we started to where we ended by simplifying the expression.